Hi YouTube, my name is Mike Hollyman and this is my first Raspberry Pi project. Before I start, I want to give a quick shout out to Sean Cannell and all the folks over at Think Media for inspiring so many people to create their own videos on YouTube. Thank you. If you're here, you may already be a Raspberry Pi enthusiast. If not, I hope you might become one after watching this video. This project is one that I first started several years ago. I've been using a Raspberry Pi for a few years, but I hadn't really come up with a project that I really wanted to do with the Raspberry Pi to showcase all of its capabilities. While I think it's interesting that some projects use garage door openers to connect them on the internet so you can use your phone to open up your garage door opener, it just didn't really appeal to me as something we really need to do. I'm a strong believer that a good project should have a few requirements. First, it needs to address a problem. Second, it needs to make something better. And third, it should ideally replace some existing thing, not just add to it if possible. And last, it should start small so you can make some good progress initially and then have a roadmap to bring in future enhancements and additions to the project. So with all that said, my first project is an LED matrix based swim meet sign. This is what the sign currently looks like. It has two 64 by 32 pixel LED RGB matrices from Adafruit. It's powered by a single Raspberry Pi. About any model will do. I think this is the Pi 3 Model B. Before I get into more details of the build, let's demo what the sign does. If you've ever attended a swim meet before, you'll know that it is an almost all-day event. These can have 100 or more swimmers, and there are 90 individual events. Most events have multiple heats of the same event, so you could have 1, 2, 3, even 4 different heats of the exact same event. Say if it's the boys 7 and 8 25-meter freestyle. You're going to have a lot of kids that participate in those particular events. And that makes for a lot of different heats that you have to pay attention to at the swim meet. If you notice on the sign, I have the two LED panels. The left one is surrounded in blue, is the current event and heat that's in the pool. So if, for example, it's 2-1, then that event is event 2, heat 1. As the heats increment, this will also change to 2-2, 2-3, etc. until it gets to the next event. You'll notice on the right side, bordered in red, is another number, and this is the number of events they are heating through. So if that says 16, it means that kids in any event up to 16 should be in the heating area or tent, depending on what the pool uses. Those are the two key values that people need to know at a glance at a swim meet. If your kid swims in 5 different events, those might be spaced out over the course of several hours. As a parent, you don't want to miss your kid's event, but you also want to socialize with other parents, at least until COVID-19 hit us. So why did I make the sign? Well, a few years ago we moved into a neighborhood that had a swim team, and one of our kids signed up for the swim team as a member. And what we found out as parents is that there are a lot of volunteer hours that you have to give to the swim team in order for the swim team to be a success. You may have to pick up food the night before to sell at the event the next day in the concessions. You might have to set up the pool at 6 a.m. You may have to be a stroke judge or a lap timer or other adults that are working in the heating area, etc. There's a lot of different positions that are spent in the swim team event. So one such job was a card turner for a sign to help everyone know what event was currently swimming in the pool. At most pools, this isn't a very meaningful sign. That gets to my first requirement is it must address a problem. These old signs are typically made out of PVC piping. They have cards with numbers on them that are laminated and then placed on hooks that you flip over on the sign to increment each of the events that's going on. These are typically really short, right? Because the person can't flip the cards if they can't reach the cards, which means it's really hard to see them. So if you're either far away and the other side of the pool, or if you might be sitting down and have someone standing in front of you, it's really hard to see these signs and understand what event is actually swimming in the pool. So that meets my first requirement, address a problem. It also meets my second requirement of making something better. With my LED sign, you can see it really well in bright light. And I could talk to you about one version that involved a large TV one year. Yeah, that didn't work out. You can also put it up on the fence to make it high enough for people to see anywhere in the pool area. And you can even have multiple signs if you want, all in sync with each other if the pool is large enough. So this scales out really nicely to whatever size pool you have. It also addresses my third requirement of replacing something that already exists. So certainly with this sign, there was no need for that parent volunteer to flip the cards on the PVC signs. In fact, the sign is so simple, with the remote that I created for it, any person can do this, whether it's the announcers at the pool or another parent volunteer, to update the sign events. That meets my last requirement, which is to start small so you can get some good wins and then have a roadmap to provide additional features. My first sign worked out great the first year, but I had to manually update all of the events using my laptop computer and an SSH session to the Pi. That didn't work out really well for scale, and I'm the only person that was able to control it. Later versions had a mobile web app that allowed you to connect to the Raspberry Pi's web interface and then update and increment the events that's going on, but that didn't work out that well either because keeping your phone out on a hot day in the sun, it was hard to see and you had to constantly unlock your phone. The current version includes a Wi-Fi remote now to update the sign. And that was cool because I also got to experiment with 3D printing for the case and using an ESP8266 microcontroller for the remote. So let's discuss the system. It's evolved over time, and right now it's based on the Raspberry Pi. I also picked up the Adafruit RPi RGB matrix hat for it. This greatly simplifies the cabling of the RGB matrix, and it also has an internal clock if you need to use that. But the best part of the matrix hat is the cable connector. It connects directly to the matrix itself. This makes the cabling very, very simple. The two matrices are daisy-chained together to make one large display of 128 by 32 pixels. Originally, I started with a single panel and it just wasn't large enough to be seen across the pool. Then I used two separate units with two Pis at different locations, and that wasn't much better. Ultimately, I put them side by side and used one for the event and one for the heating through. The wider screen also works great for combined events where two events are different events are swimming in the pool at the same time due to just having a few swimmers in each event. I use a scroll for that so that all the combined events will be displayed at the same time. The Pi runs a Python script that uses a library from Adafruit to display to the matrix. And that constantly runs and updates and looks for any changes in a Redis in-memory database. When the event or heating changes, the sign will update the appropriate section, and this makes refreshes quick and it doesn't need to redraw the entire screen. I use Redis on the Pi as a way to keep a key of what the current event is. This is a single entry for the event, and that includes the event, heat, and heating through. Any changes to that are updated at the sign. I run a Python Tornado web server on the Pi 2, and this is for local clients to access the stats. So this lets people check the event on their phones if they're farther away but still in Wi-Fi range. And this is also good for people working in like food concessions or in some of the back rooms that may not have a view of the sign. They can easily use it to check to see if their kid's next event is coming up soon so that they won't miss it. In the past, I also used a cloud VM as part of the sign. So I used a cloud VM that had a tunnel established from the Raspberry Pi to the cloud, and it synchronized the Redis server keys and the Tornado web server at the same time. That way it was actually available on the internet and anyone could see it from anywhere they are. For parents that might be at home during a swim meet and having to take care of another little kid, for example, they could still keep track of exactly what the events are that are in the pool so they know when they need to start hustling back to the pool to make sure that they could see their kid's event in time. Lastly, this past year I built a Wi-Fi remote for updating the sign. The ability to update the sign was the weakest link by far. I tried an RF key fob and that was horrible for distance. The phone app that I made was a pain to use. And I needed something super simple so that ideally the meet announcers could even update it as they call each event. I came up with an ESP8266 microcontroller that includes two arcade buttons also from Adafruit. I used the Adafruit Feather Huzzah, which let me charge the LiPo battery for the remote. It had built-in Wi-Fi and it was also really easy to prototype on. A 3D printed box for the arcade buttons wrapped up that part of the project. You can get all different sizes of batteries for the Featherboard, and here I'm using a 2000 milliamp battery, and that lasts plenty long for the entire event. To program the event, the meet, a simple CSV file is used. So I create this based on the heat sheets that are released the night before the event once all the swimmers are committed. That gives me how many swimmers are in each event, what the order of the events are for the pool, especially with what events are also combined. And this also helps out with heating through. So for example, if I have capacity for 35 swimmers in my heating area, plus swimmers on deck, plus the swimmers that are currently in the pool for their event, I can then count up and understand how many swimmers need to be sent to the heating through. This is kind of a weak link in a lot of swim meets that are out there, where the announcers just kind of tell kids to go to heating through at a certain time. And what you end up getting is a lot of kids stacked up in heating, and they don't want to be over there and they want to be playing. So this allows us to very, very smoothly predict how many kids need to go to heating and make sure they get there in the appropriate time. And it's also great for later on in the swim meet when you have longer events like 200-meter races, for example, that take a long time to actually run. So this helps overall. It makes the swim meet run a lot more smoothly. The CSV file is loaded up into Redis as key value pairs for the sign. Once that's loaded up, all we have to do is get the sign mounted on the fence, and then it's ready to go. So I made the sign out of 2x4s and placed a crossbar at the bottom that rests perfectly on the top of our particular pool fence. The Velcro then holds this sign to the fence, and then I use zip ties to also make sure that it doesn't fall off. So the overall design looks like this diagram. We have two matrices connected to the RGB matrix hat that sits on top of the Pi. A Wi-Fi router is pre-configured with static DHCP addresses for the Pi and the remote. The remote is programmed for the same Wi-Fi. I also have a second Wi-Fi router, and I'm repurposing an old Airport Express from Apple that it plugs into the main Wi-Fi via Ethernet, and then it joins another Wi-Fi network for internet. And this is really slick in that I can leave the sign and remote Wi-Fi and IP addresses all static, but if I need to take it to another pool, I can simply use the local pool Wi-Fi for internet access. I don't have to change any of the addresses that I use on my sign at all. The remote then uses the MQTT protocol over Wi-Fi to publish to the MQTT server for increments and decrements to the meet. That is really simple, and it's an easy way to implement it in Arduino, and also makes it super fast. So that is my swim meet sign. I've had a lot of fun building this project over the years and making lots of enhancements to it over time. I do have additional features that I would like to implement, but I think that some of the swim meet software these days might be starting to catch up in feature functionality. Some of the things that I've prototyped in the past include taking a list of all the swimmers and their names and their parents' phone numbers in each event, and then being able to send a text message or a push notification to those parents right before their kid starts to swim. So parents typically start talking to each other during the events, and these events, some of them are really short, and they look up and all of a sudden they see their kid climbing out of the pool and their event's over with. And parents hate to miss those events for their kids. So I think functionality like that, where you can give parents notification about when their next event happens, would be really, really critical. So that's it for my swim team LED RGB matrix project. I'd love to hear what your thoughts are. Please comment below and let me know if there's any features you want to know more about, if there's other things you think I should be doing. If you'd like to learn more about things like the MQTT protocol or the Arduino code, or how I'm actually drawing things on the screen, let me know in the comments, and I'd be happy to do some follow-up videos for this, or maybe a blog. And if there's interest in it, I am considering putting the software up on GitHub or Bitbucket as an open source project. Maybe some of you watching might want to help out, and we can turn this thing into an even bigger project and make it even better. So that's it for my swim team video. Thanks for watching. Until next time, be a decent person, make someone else's day better. That's way more important than a like or a subscribe to this channel, although you can do that too.